Hey everybody, how we doing today? Kind of a rainy, windy day outside, so I thought I'd make this video that a lot of you keep asking for through the messages and the comments. And basically what we're going to make today is a quick, easy GM cluster bench tester for the 03 to 06. I'll probably make this video in two parts because it may take a while, and then what I'll do on the second part is I'll show you how to add, and I'll show you my bench tester that I use, how to add quick connect so you can take it apart and plug in a connector that's got the pins in the right configuration to do the 99 to 02s. So for starters, basically, I'm going to build this one out of a box I got on Amazon. It's an aluminum enclosure. Looks pretty cool. It was cheap. I think it was about $14. It's 8 inches by 6 inches by 4. A little more than what we need for this particular one, but it will look nice and it'll work. I bought a volt gauge. You don't have to. This was like $4, but I like to see if the cluster is pulling too much power. You'll see a dip in the voltage right away, and then you know you can shut it down. I have various switches here that have come out of my drawer, so we're going to need a couple of, for sure, a couple of latching switches that lock. And if you wanted to use momentary ones, all these switches are pretty cheap. Just make sure they're a 2-contact. We're going to need some wire. These here are optional as well. They screw into the enclosure, and then when your cables come out, you can tighten them up, and it keeps you from ripping your wires out of the box. You're going to need, also optional, you can cut your power supply and go directly into the back, but I use these jacks. They're just a standard DC jack. And then we're going to need some wire, of course, and you're going to have to get yourself a GM connector. This one here is, I believe, a radio connector, but they're all the same. You just want one with most of the pins filled up. Try to get the original cluster connector. I think now you can order them aftermarket, if I remember right, for the cluster. They're about $15, but I have a bunch of these on hand, so I'm just going to go ahead and use this one for the sake of the video since I already have a tester, and we'll use that. This one here doesn't have the little grooves where it clicks into the cluster, or in the wrong spot on the top, so I'll just sand those off, and then I'll write top on here, because if you do it that route, it's very important to label the top, because it will go in upside down, and then you'll end up burning up a cluster. For this one, also optional, this came out of a GPS unit. I used to do installs on GPS units for some of the rent-to-own car dealerships around here. We're going to cut this off, and I'm going to add an Obd2 connectors in case we want to run a scanner into the cluster. And then all you need is a 12-volt, minimum 2-amp switching power supply that you can pretty much take from any household device, router, anything that has it, or you can buy them on Amazon. I think they're like $8. I'm trying to do this on a budget for people that want to build a quick tester, and it should have the positive inside and then the negative outside connection. And the reason why I like to use a connector instead of wiring the power supply directly into the box is because if I ever want to take this with me, I can also use a car adapter, which has the same connector on the end. Sorry, I'm not trying to ramble through this video. It has the same connector on the end, so we can switch it from either using it on the road or using it at home. I don't know if I already said it, but we also have some wire we're going to need, soldering iron, solder, and this is just some wire wrap to make it look nice when we're all done, and some electrical tape. So there's not a lot you need. The main thing, I guess, would be the box that you choose to use, and then the GM connector. The rest of the stuff you can kind of find around the house, and I like having the Obd2 connector also built into my box, so I can use either a scanner, or I can use the Tech 2 software on my laptop to get into the cluster if you want to do a sweep test, or if you have intermittent problems. So first thing we're going to do is I'm going to take this box and I'm going to mark it with a Sharpie, and then we're going to get the holes drilled. Okay, so here's kind of where we're at. As you can see, I did a piss poor job on this one, but it's more the point of this video and not so much as a necessity on my part. I do have 2 testers I've built, but what I've done here is I just drilled all the holes, which you can lay it out however you want. And what I have here is this is going to be for our main power. This is going to be to toggle the lights on and off. And this is going to be to toggle the turn signal hazard lights on and off. So we can test both of those and not have them on blinding us the whole time we're repairing a cluster. This right here is where our Obd2, or not Obd2, sorry, this is where our connection is going to come out to go to the cluster, and right here is going to be for our Obd2 connector, and we have the power jack on this side. Fairly simple. I drilled these holes crooked and it's driving me crazy already. And then I didn't have the exact right hole saw, and you can see that I scratched it putting it in there, but neither here nor there. At least we have the concept done. So next, oh, and then one more thing I wanted to add is I have these cool little things that I use. I build guitar pedals, and I actually have a channel for amp repairs and audio equipment, and I use these a lot. They're just little LED holders, and they're pretty cool. They screw in. You can put whatever bulb you want in there. So I put one green and one blue. I'll probably surprise myself which one is which, but we're going to wire those up. My other tester, I actually didn't do this, and I wish I would have. I might add them later, and I'll show you guys my other tester. So when I have the power on for the lights, I know that it's actually getting power, because there's been a couple times where I had a bad connection, and I was trying to hunt it down, and it actually ended up being on my tester, wasn't outputting for the lights and not the actual back of the cluster. But long story short, we're going to have an LED come on when each one of these circuits is turned on. So if we turn this on and both of the turn signal lights aren't lighting up and we have power here, we know that it's in the cluster itself. So simple start. We left more room here for add-ons later, and I'll have to show you on my main tester. Right here I have an 8-pin, it's a screw-on type connector, and what I've done is I've built an adapter for each year and crossed over the pin. So if I'm working on say a O2 Trailblazer cluster, I can just quickly unscrew it and then screw in the terminal with proper terminations on the connector for the O2, and then vice versa for the O2 99 to O2 clusters, and then the 05 and 06, and I actually have one for the 07 to 010, so that way I don't have to keep going back and forth. I mean, technically you could add each one because the pinouts are different, but it's much easier to have an 8-pin connector here and then just change them on the opposite side of your cable. But this will get you by if you're just mainly into the 03 to 06, which is 99% of your repairs, other than the display going out on the 2007 to 10s, and then the earlier 99 to 02s, which don't fail as much either. So this one will get you by for a lot of the clusters you're going to do, other than the Trailblazers, which do have the same issue with the stepper motor. So for right now, what we're going to do, we're going to flip it over, and we're going to try not to drop it. We're going to solder in all the common grounds we need from here to the LEDs, and then the switches are going to be positive only, and then we're going to need a negative here. So we'll solder the grounds in right now, and I'll show you what that looks like. Okay, so what I've done here is make it seeable. My ground comes off of our input jack. It goes up to the negative side of the gauge, which if you don't have a gauge, you don't need to worry about it. It's soldered onto the gauge. And then I have an extra lead coming out ahead of time for the Obd2 connector ground and also the cluster ground. So we have them all three tied in there. And then what I did was 2 small grounds go across to the LEDs. And if you know how LEDs work, they are negative and positive directional, and the positive lead is always longer. So what I've done is I've connected the two negatives together, and then on the positive side, they've always got to be resisted. These are blue and green, which I think you can get away with a 470 ohm resistor to keep them from burning out. So what I did instead, I don't want these lights to blind me when I turn the switches on. I just have, I believe, a 1K resistor. I upped it a little bit, and I just looped them through on the output side of the toggle switches. So where these LED wires are hooked up, those are going to be the output power that's going to go into the connector for the cluster. So it's pretty simple. We have the grounds daisy chain there all together off of the input jack, and now we're going to wire up positive lead, similar idea, and I'll go ahead and do that. The only difference is that the positive is actually going to go from the switch into our first switch here and then onto the gauges. So this will kill the power for the whole entire supply. So let me go ahead and wire that up, and I'll show you where we're at. Alright, so what I've done next is I've soldered the opposite side of the jack. The output, the power side, goes into a fuse, and I've used 2 1/4-inch female automotive heat shrunk connectors. And for the life of me, I can't find my fuse kit, but there's a 40 amp in there right now. Just for the sake of the video to show you, I would use a 5 amp just as a precaution. I know a cluster with factory bulbs will pull like 1.4 amps when you first turn it on, so definitely use something a little higher than that. 5 amp would be fine. And we have that wire, and it runs over to our first on and off switch. So that power is going to come in, and it's going to hit this switch. And then on the next side of that switch, we have an output. It's going into our gauge if you have one. Kind of an ugly solder job, but it's actually solid and it's good. And then that jumps over to the opposite side of the LED on your next switch, and the opposite side of the LED on your next switch. So basically what we have now is power here. When you turn it on, we have a constant 12-volt source coming out of the gauge side, and then we have 2 switched 12-volt sources coming out of our smaller switches. That's going to be for the turn signals, and to test the turn signal bulbs, and to test the backlight bulbs. So we have 3 12-volt circuits going out, and we have 1 original ground going, so we can use the same ground for everything. At this point right now, I'm going to plug in the 12-volt adapter, and if everything's fine, we should get a gauge reading, and our switches should be working. Alright, so I went ahead and connected the power supply. Obviously I tested it first. So this is going to be our on switch for when the cluster is connected. We can turn it on. And then what we have here is, this one will probably be for the hazard turn signal bulbs. So we can check those on their own circuit. And then this one here will be for the backlights on the cluster. And I have a little label maker. I'm going to label these just so I know. But it's nice to have. You really don't need this feature. I mean, any 12-volt supply with the right lines can power up a cluster. But, you know, when you rebuild them on a level like I do, and you have them apart, and you're constantly testing the LEDs. My first tester didn't have an on and off switch for the backlights, and then I ended up adding it later because they will start they're so bright. You know, you're doing the LED upgrades, you're turning it on and off to make sure everything's positioned right and working, and if they're on the whole time, it'll blind you. You know, it's irritating. So it's nice to have those 2 options, and the same with the turn signal bulbs if you want to convert those to LEDs. It just makes it nicer. Or when you first get a customer that brings you a cluster, or you grab one and throw it up here on this little tester, you just turn it on with everything on, and the cluster should come on. All your lights will come on, everything will come on, so you kind of know where you're at with it. When I rebuild them, I do everything at once, but some people like to do piece fixes. But this unit will be nice. It'll show you which bulbs are burned out. on the backlights, and it'll show you if your turn signal bulbs are working, and it'll power up all the gauges and everything on the cluster. So next step, we're going to connect the Obd2 connector and then get our wires routed here, and then we'll get the J1850 line connected, so we will be able to scan the cluster if needed, and we'll start going with that. Okay, so now we're going to move on to some of the more important parts, actually assembling the connector. So basically, I'm going to try and show you guys the best I can here what we're looking for. And you should have your GM 24-pin connector. Like I said, this isn't specifically for a speedometer, but it's or instrument cluster, but it's the same connector. I'm just going to file down the one pin that keeps it from sliding in the back. Anyways, onward. Here are the pins we're looking for on this connector. Now, if you were to take the top here, just clips on with two little clips. You can spring them out. You can see the hooks right there. This comes off, and if you look at the back of this connector, I don't know if you'll be able to see it right there, but you have A1 through A12 and B1 through B12. So it's nicely labeled for you. And I've broken down here on what we need. So what we're going to do is we're going to look for A6. 1, 2, 3, 4, 5. Okay, so this is A6 here. This is going to be our data line. And then we need A8 and B1. We're going to hook those together. So A6 will move over 6, 1, 2, 3, 4. Okay, I'm sorry, A8. And then we'll go down to the bottom row, and B1 is easy to pick out. So these are going to be the ones we use to power up the turn signal bulbs to make sure they're working. By the way, all the other bulbs on these clusters, if you have them apart, you obviously know are LED. And usually when you first fire up the cluster, you get all the lights to come on. Turn signals don't, and the back lights don't unless you power them. But all the LEDs, like the airbag light, check engine light, etc., they all come on and do like a intermittent, real quick check. So we don't need to power those up specifically. Just powering up the cluster does that. So not to get sidetracked. So right now we have A6. This is going to be our data line. This one's going to go to the Obd2 connector, which is going to allow us to talk to it with our scanner if we want to. And then A8 and B1, we're going to merge those together for turn signals. And then we have A11, which would be the second to last on the top row. So A11, this is going to go to our switch on our controller to turn on and off the backlights for the gauges. And then we have A12 and B12, which is kind of nice. The very two end ones are going to be grounds. So we have two ground, backlights, data, turn signals. Now all we need is our power, and our power is going to be connector B9 and B11. Easy enough. B11 is right here, and then we'll go over two more, 10, 9. So this is going to be the power. Now what I'm going to do here, I don't want to remove all of these wires out of this harness just in case I end up using it later or needing a pin. So I'm going to cut them off, and now we can pull this back because I know where they're at. And we have the longer ones we're going to use, the shorter ones we're not. So we prepped this connector, and I'll leave this here for you for a second if you need to see it. And that does say B9 and B11, and that's battery plus voltage. And A12, B12 are ground. A11, backlights, 8 and B1 turn, and A6 is data. That's all we're going to need out of this connector. And again, you can see here, B1 works its way across. A1, it's opposite the connector view. But when you look at the diagrams, so what we're going to do is that, and now that I have the ones I need, if you bought a connector which I just looked it up, and you actually can buy these connectors specifically for the GM clusters, new replacements. I'm not sure if they're aftermarket or not, but they come without the pins. So you buy the connector, and then you just click the pins in, and then lock this top one. But me personally, when I build my testers, I like to leave all the wires there, because that way I can heat shrink it, and I have more sturdier connection when I plug it into the cluster. If you just use the 4 or 5 wires, 6 wires, it's going to be kind of flimsy on the end. So that's why I cut these ones shorter, and then we'll heat shrink it up nice, and it's a more sturdy connection. So that's it for that one. And then your typical Obd2 connector, same thing, pins 1 through 8 on the top. I have it ready for you guys here. These are the connector pins. Looking at it from this view, you have 1 to 8, and then 9 to 16. So what we're looking for on this one, and I've already done it conveniently, this is out of a GPS module. It's an Obd2 extension, but number 16 is power, and then let's see, 5 is ground, 4 is also a signal ground for the data line, but we don't need to worry about that. So all we're going to use out of this is pin 16, pin 5, and then on the bottom here, pin 10 will be our data line. So 16, 5, and 10, and then I did the same thing. I cut the harness shorter. This one's going to be easier to remember because we just have 3 coming through. And now what I'm going to do is, actually I did it already. On our tester itself, let me zoom out a little here. I ran the wires I needed through, and then they're here on the back. I didn't want them too long inside the box. I believe I ran 6 wires through, and the reason why I like these little connectors here is you can move the wires, and then when you turn them, they actually lock, and you can pull pretty hard. You ain't gonna get that out of there. Just to be safe, on the back side, I put a zip tie here, and then you can use whatever color wire you want. I used 2 orange pieces that I had, and then there's a bunch of white ones. So just to save myself some time in the long run, I marked them, each one, so I know end to end. I don't know if you can see that. Number 3, and then on the inside I did number 3 here, and then our Obd2 port. I don't know why it sounds funny every time I say that. I'm gonna heat shrink these here, but it's gonna be the same concept. We're just gonna have a short extension port hanging out the side. This will be heat shrink nice, locked into place, so if we want to plug a scanner into it. I could have took the time and cut the hole, because this is your typical Obd2 connector, snaps into a square hole with a slot, but it takes forever to file that hole and get it just right. And I think the last one I did, it was sloppy in there, so I just do it this route. I'll let it hang out the side. Got the wires here, so now what we can do, we're going to terminate the power wires all together, ground wires together, and then we're going to have our data wire tied in, and we'll get this put together. And last but not least, we'll finish up our connector, make all the wires look nice, and then put it back together. Okay, so I pretty much finished the inside of this test unit. Fairly simple, as you can see. When I ran the 6 wires out to the connector, there is an extra one just in case I ever need it. So that one's folded over, and basically all I did was I wrote myself a little chart here, because I have the same colored wires going through. So basically I connected the power for the Obd2 port. Sorry, I'll try not to be so shaky. The power for the Obd2 port coming off the main power is also tied in with the power that goes out to the cluster. The data line goes directly out to the data line for the cluster, and all 3 grounds are tied together. And the reason why we need power on this Obd2 port is most scanners aren't self-powering at the connector, especially like me. If you like to use the Autel, the wireless, you're going to need 12 volts here on pin 16, and you're going to need a ground for it to fire up that connector. I went ahead and taped off the rest of the wires I left in case I ever need this connector again someday, and then this is nice and tight, so we're snug there. Everything else on the inside is finished up. I put a little bit of electrical tape just to be safe around the 12 volt connector. Doesn't really need it, but better safe than sorry. Made sure my LEDs are all locked into place. The resistors will keep these wires from touching the aluminum and shorting out. So basically everything inside is done. All we have to do now on the outside is connect 5 of these 6 wires up to our connector, put a little cover on the outside of this wire, and our tester is complete. So what I'm going to do now is I'm going to grab the connector, and I'm going to solder these wires together the way I did it. Blue is ground. These are a heavier gauge wire. Red is my 12 volt plus, and then the data line is the wire with 4 lines, and the turn signal is a wire with 3 lines, and the wire with 2 lines is for the backlights. And then I have 1 spare wire in case I ever need it, or if I decide to change this one to the 07 and up style cluster, I'm going to need the extra wire. So right now I'm going to solder and heat shrink these together, and we'll see what we get. Okay, and we're pretty much done building the tester. What I did here was pin for pin. You know, we have the 2 turn signal wires terminated, and we have the data line terminated. We have our power, ground, and backlights terminated, and my extra wire is right here. So what I'm going to do is just dress this up a little bit, make it a little more sturdy, and we should be done. We'll be able to test a cluster. Okay, so I kind of like this cloth mesh wire wrap that I have. I did a fuel injection conversion one time on a truck, an older truck, and it came with about 10 rolls of this, and I have a lot left, and it's pretty cool stuff. It's flexible. So basically, yeah, this is what she looks like. Very simple build. I got a lot of people asking me for it. I'll go a little more in depth in a later video about my other tester that I built, and with the different sockets and or with the different year connectors, and how I made it interchangeable. But if you just want to build a simple one, and trust me, if you rebuild a lot of these GM clusters, having a test unit even as simple as this is a huge help, because otherwise you got to go pin for pin, or you're guessing, you know, when you can just turn it on, zero out the gauges, put it back together. You know, I can do them in 15 minutes in and out the front door for customers of mine. It's a very valuable little box. The only reason I would say to maybe try and source a better box is this one I got on Amazon. It's really light. My intention was to make this video. All in all, it cost me about $45 to make this. One more point I also want to make is, if you're going to use the Obd2 portion and power like a pass-through or power a connector, you might want to go with like a 12 volt. I found a different one. I have one here, and I looked this up on Amazon too, and I think it was $8.99, but it's 12 volt 5 amps. So I know your cluster is going to pull 1.4 at a peak, and you want to be able to make sure that your connector doesn't quit communicating if you're going to use that route. But this will work just fine. I'm going to grab a cluster. I will show you how it works, and then finish screwing it together. But my point was, I grabbed a lighter one here because my plan was to put a 12 volt NiCad battery, not a lithium, just a 12 volt NiCad, and then actually keep this in my van as kind of like a portable in case I ever do one, you know, on the road without bringing it back home. And yeah, just make it kind of rechargeable. You know, use a high milliamp 12 volt NiCad battery pack in the bottom to weight it down. If I end up keeping it at home on one of my benches, I'll probably screw it to a piece of wood or double-sided tape it, because I could see it driving you crazy if it moves a lot when you're trying to plug in a cluster. But let me grab a cluster. Ugh, I can't talk, it's getting late. And we'll plug it in. We'll make sure everything works and finish up this video. Okay, so here's a cluster that I just got finished repairing. It's out of an 06 and the display was dead, so that'll be a video for itself, fixing the 06 displays. So on the connector on the end of our tester, what I did here is I just, since this is out of a radio and not actual cluster connector, I just shaved down with some flush cutters the bottom two tabs, but I left the top two because they are the same. So this is now going to plug into this cluster, but only in the one direction, so I won't be able to plug it in upside down and burn out the cluster. And then also what we could do is pop off these little connectors here. Let me grab a screwdriver. Okay, so I loosen these up with a screwdriver, that way they just pop right out. Sorry, I'm one-handed. Should have put this back on the tripod. Thought I had them loose, but anyways, the whole reason for doing this, there you go, is you just push those two hooks. I'm going to leave this off. That way when I put a cluster on the test bench, I can plug it in. This will only fit one way, but then I don't have to squeeze the tab over and over. And I'll just show you the benefits. Sorry about the messy bench, I've been busy. Like I said, the two tabs, so the connector only fits in one way. We're just going to slide it in. And now we're going to test out our tester. Let me get this light out of the way, and when we power it up, there we go. We now have 12 volts running. Our cluster's on, and then from the button here we can test turn signals and the backlight bulbs. This one here I put ice blue bulbs in it for them. They're the little triple diode LEDs. That's all I use because it doesn't give you hot spots in your cluster. So and another one of the benefits to having a tester is setting the needles. Basically you're gonna let it power down for a minute, and then you want it to kick on, and then you hear the gauge motors move. Sorry about that. And then once they stop, we know we're in the neutral position, and they go on just below the 0 point. Now, when we repower it, you'll see them, they'll jump down a little bit, and then they'll come back up to just below 0. That tends to be the neutral position where you want all of your gauges after you replace the motors on these. So that's all there is to it. You just built a little test bench. We have about I think $35 total. I can show you the box and everything I bought. If you need, just ask in the comments. But that's all there is to it. And maybe I'll make another video on communicating with the cluster, testing the cluster, and actually how to make the pigtails for the various years. So thanks for watching this, and hope it helped you out.